This is units of heat and conversions involved with those units. So when we start working with heat, the first thing the textbook is going to give us is units of joules. And they'll give us conversions into units of what we're going to call lowercase c calories. So we think of burning calories when we eat or exercise. This is kind of what they're talking about. Okay, the primary definition for heat in science is the joule. But we often see it in calories, and we often see it in what we call capital C calories, which are equivalent to kilocalories. So I probably should add that here also. 1 capital C calorie is equal to 1 kilocalorie. So that's not necessarily a conversion that we're ever going to use, but it's something we need to know. It's the reason why these two equalities are the same. A capital C calorie is what you see on your cereal box. And so ultimately the American public didn't want to know that they were consuming 224,000 joules of energy a day, or even 22,000 little c calories, which is why we use that capital C calorie or kilocalorie, because the American public is much more used to and receptive to knowing that they take in somewhere between 1,800 and 2,500 capital C calories per day. So those are just a kind of a quick run through of the 3 heat units that you will see. And we don't really care all that much. It's just kind of like saying, well, is that distance measurement in inches, centimeters, or feet? Well, they're all units of distance. Just which one do we want to use? So along these lines here, we've got some conversions involving our units of heat. So first, to take 25 calories into joules, we're going to put 25 calories here. We know over here we're trying to get into units of joules. So starting point here, ending point here. We put our starting point over 1. And we're going to use the conversion that converts us from lowercase calories into joules. We're looking to cancel lowercase calories, so we're going to put that on the bottom. And we're going to go to units of joules, so we're going to go ahead and put that on the top. And like we've done in the past, we wait until this point to write our numbers in. So again, every conversion factor comes from an equality. So in this case, 1 lowercase c calorie is equivalent to 4.184 joules. I also should put 4.18 in here because sometimes in texts you'll see it stopping at the hundredths place instead of the thousandths place. So we're now ready to go. We have 25 calories. It's a multiplication problem. So we have 25 multiplied by 4.184. So we get 104.6 joules. And if we wanted to go into significant figures with scientific notation, we could say there are 2 here. So we're going to take the 1 and the 0. Does the 4 round the 0? No, it doesn't. So this would be approximately 100 joules. And in terms of that 2 significant digit game, this is interesting. We would actually say 1.0 times 10 to the second joules, maintaining the integrity of 2 significant figures in the original problem and 2 significant figures in our final answer. Next, we're going to go from kilocalories down into calories. So 1 kilocalorie is 1,000 calories. So here we go. So 2.5 kilocalories over 1. And we're looking to get to units of calories. Again, it's important to put the unit that we're trying to get to over here, so we know, hey, we're starting here, trying to finish up over here. So once again, we're going to put kilocalories on the bottom and calories on the top. And we know that for every 1 kilocalorie, or 1 capital C calorie, there are 1,000 regular calories. Didn't do this on the previous problem. We're going to go ahead and cancel out calories here. We're going to cancel out kilocalories. So we're going to go 2.5 times 1,000. So we're going to get 2,500 lowercase or little c calories. We wanted to put that into scientific notation. Again, 2 significant figures in the problem. We're going to put 2 in our answer. So 2.5 times 10 to the third lowercase calories. We're done. Now we have 2,000, for problem 3, we have 2,520 joules, and we want to get those into uppercase calories. Well, we don't have a joules into uppercase calories conversion, so we're going to go joules into lowercase calories, and then lowercase calories into uppercase calories. So if we wanted to write the plan out, we could say we're going from joules into little calories, and then from little calories into capital C calories. And each of these arrows represents a conversion factor that we're going to have to do. So this is going to be a 2-step conversion problem. So here we go, 2,520 joules over 1. We're going to get this into capital C calories. So we'll put that here. The first conversion is from joules into lowercase calories. So in this case, joules on the bottom and lowercase calories on top. Numbers wise, there are 4.184 joules in 1 lowercase calorie. So joules will cancel. And we're going to go, now we're in lowercase calories, but we want uppercase calories. So we're going to go one more step. We're going to put lowercase calories on the bottom and uppercase calories on the top. And there are 1,000 lowercase calories in 1 kilocalorie or uppercase calorie. So calories cancel. The only unit we have left in the problem is capital C calories. And that's the unit of our answer. So now we're ready to go. It's 2 steps in our calculator. It's 2 divisions. So we're going to 2520. We're going to divide by 4.184. We're going to hit equals. So we're halfway there. We're going to divide by 1,000. So we get 0.60229 extending. So we've got 3 significant figures here in our original problem. So we're going to go ahead and put 3 in our answer. So we're going to take the 6, the 0, and the 2 is not going to round this 2 up. So we're going to go with the final answer of 0.602 capital C calories. I could put that into scientific notation if I wanted to. It would be 6.02. This is a small number, rolling it 1 time, times 10 to the negative first calories. One more 2-step problem to finish it up. We have 2.5 kilojoules into lowercase calories. Again, we're going to put our method right here. So we're going to go from kilojoules, and we're going to first convert that into joules. And then once we have joules, we're going to go into lowercase calories. And so here we go. 2.5 times 10 to the second kilojoules. And again, over on the far right, we're trying to get into lowercase calories. And so we're going to cancel kilojoules and get into joules. There are 1,000 joules in 1 kilojoule. So kilojoules are going to cancel. And then we're going to go from joules into lowercase calories. So joules on the bottom, lowercase calories on the top. And in every 1 calorie, there are 4.184 joules. We've got a multiplication problem and a division problem here, so here we go. Take care of that number in scientific notation first. We go parentheses 2.5 times 10 to the second. Close parentheses, this is 250 kilojoules. I'm going to multiply by 1,000. So 250,000 joules. Divide by 4.184. So I'm going to get quite a big number, 59,808. Go ahead and put that here. 59,808. But again, in terms of significant figures, I have 2 significant figures here. So I only want 2 in my answer. So I'm going to take the 5 and the 9. And does the 8 round the 9 up? Yes, it does. So this is effectively 60,000 lowercase calories. If I wanted to put that into scientific notation showing the correct number of significant figures, again, 2 in the original problem, so I'm going to make myself have 2 in this answer. So I'm going to say 6.0, just so I have 2, times 10 to the 4th lowercase calories. And we see again, while the American public uses uppercase calories because they're easier to deal with. And we'd much rather say I had 6,000 calories over the course of a couple days as opposed to 60,000. Put a box around my final answer, and that is a little bit about converting between units of heat, which again are joules, lowercase calories, and uppercase calories, also known as kilocalories. Again, we don't care what unit they're asking it for. It's kind of like a length situation. We just give them the unit that they would like us to generate for them when we solve problems.